Assalamualaikum and hi everyone. This is me Adini Sofia. This is Intan Kalia and Norain Jafri. The last one is Jericho Adri. So, introduce to the group members. Hi.
In this video, we'll explain the basic idea of differentiation in calculus. The definition of differentiation is the process of finding a derivative which shows how a function changes, or in simple terms, its rate of change. Think of driving a car. The speedometer tells you how fast your position is changing. That's exactly what derivative does. It tells you the instantaneous rate of change. The derivative is defined using limit f prime equals to limit h approaches to 0 f x plus h minus fx divided by h. This is called the first principle of differentiation. So quick example. If fx is equals to x squared, the derivative is f prime equals to 2x. This tells us the slope of the function at any point x. Now, I'll be explaining the basic differentiation rule. Let's begin. First, we have constant rule. In constant rule, if you differentiate a constant number, the answer is always 0. For example, if you differentiate 5, you will get 0. Next, we have power rule. In power rule, when you differentiate x power n, just bring down the power and subtract the power with 1. For example, if you differentiate x power 3, you will get 3x squared. And next, we have constant multiple rule. In constant multiple rule, if there's a number in front, keep it there. For example, if you differentiate 4x squared, you will need to keep the 4 in front and take the power down. So you will get 8x. Next, we have sum and difference rule. In sum and difference rule, we will need to differentiate each term separately. For example, we will differentiate x squared first, and we will get 2x. And next, we will differentiate 3x to get 3. So the answer will be 2x plus 3. Next, we have product rule. In product rule, when multiplying two functions, we will need to use the formula uv prime plus vu prime. Next, we have quotient rule. In quotient rule, we will only be using quotient rule for division. The formula for quotient rule are vu prime minus uv prime divided by v squared. And for quotient rule, just remember, bottom times derivative of top minus top times derivative of bottom over bottom squared. And next, we have chain rule. Chain rules are used for composite functions. For example, if we differentiate sine x squared, we will get cos x squared times 2x. That's it. These are the basic differentiation rule you need for MAT 183. Now, let's move on to the next slide.
Find dy dx for the following functions: a 3x squared secant x plus 2, b y equals to 4x plus 2 divided by cos x. So for the first question, a, this is a product rule, so we apply it. So you can get u, v and u prime and v prime. So u is 3x squared, while v is secant x plus 2. To find u prime, you have to differentiate 3x squared, and you can get 6x. v prime secant x plus 2, you know that secant x equals to secant x tan x. So we apply it to the question, you can get v prime secant x plus 2 tan x plus 2, and we differentiate x plus 2, and the answer is secant x plus 2 tan x plus 2. To find dy dx, we use formula uv prime plus vu prime. So we enter the value, and the final answer is 3x squared secant x plus 2 tan x plus 2 plus 6x secant x plus 2. For question B, the question is y equals to 4x plus 2 divided by cos x. It is a quotient rule. So we apply it, we get value u, v, u prime and v prime. U is 4x plus 2, while v is cos x. To find u prime, we differentiate the 4x plus 2, you can get 4. For v prime, cos x is a negative sin x. So to find dy dx, we use formula vu prime minus uv prime divided by v squared. So we enter the value, and then we expand it, we can get 4 cos x plus 4x sin x plus 2 sin x divided by cos squared x. So as you can see, 4x sin x plus 2 sin x, we can factorize the 4x sin x plus 2 sin x. We factorize the sin x, and then we get the final answer is 4 cos x plus sin x in bracket 4x plus 2 divided by cos squared x. And that's for the question 2.
For question 3, we were given y ln 3x minus e power of 2x plus 1 minus 10 for y equals 0, and we need to solve it using implicit differentiation. So, as you can see, for the first part, we can apply product rule. Y is u, and then ln 3x is v. So u prime we will get dy over dx, and then v prime we will get 1 over x. And then we insert it at formula uv prime plus vu prime. So y times 1 over x plus ln 3x times dy over dx, and then we continue with the second part. Minus e to x plus 1, differentiate the power, minus secant square for y, and then differentiate the 4y equals 0. And then we will get y over x plus ln 3x dy over dx minus e 2x plus 1 times 2 minus secant square for y times 4 times dy over dx equals to 0. And then we expand it, and we will get y over x plus ln 3x dy over dx minus 2 e power of 2x plus 1 minus 4 secant square for y dy over dx equals to 0. And then we gather the one with dy over dx together, and the rest we put it on the right side of equation. So we will get ln 3x times dy dx minus 4 secant square for y dy dx equals to 2e power of 2x plus 1 minus y over x. And then we factorize, so we get dy over dx times ln 3x minus 4 secant square for y equals to 2e power of 2x plus 1 minus y over x. And then for the final answer, we will get dy over dx equals to de power of 2x plus 1 minus y over x per ln 3x minus 4 secant square for y. That's all.
Hi, now let's solve the last question using linear approximation. We are asked to estimate the value of square root 4 80.99 minus 2 over square root 80.99 correct to the 3 decimal place. We let the function be fx equal to square root 4x minus 2 over square root x, and define it as fx equal to x power 1 over 4 minus 2x power negative 1 over 2. After that, we find the derivative of the function, that is f prime x, and we get f prime x equal to 1 over 4x power negative 3 over 4 plus x power negative 3 over 2. We will be using this formula. We choose given value equal to 80.99 and chosen value equal to 81 because 81 is close to 80.99 and it is a perfect square. Let's calculate the function and its derivative at x equal to 81. We substitute 81 in function fx and derivative of the function f prime x. We get 25 over 9 for the function fx and 31 over 2918 for the derivative of the function f prime x. After that, we find the xx using the given formula. We get xx equal to minus 0.01. Now, we apply the linear approximation formula and substitute all the values. That gave us f 80.99 equal to 25 over 9 plus 31 over 2918 multiplied with negative 0.01. After simplifying, we get 2.778. That is our final answer.
To sum it all up, differentiation helps us find how a quantity changes, whether it's speed, growth, or slope. It's a key concept in calculus with many real-world applications. Thanks for watching our video on differentiation for MAT 183. We hope you learned something useful. Bye!